Soil builds that way, and it is distinctly different in different areas. And it's improved, it supports soil plant life. It also is improved by plant life. How soil supports plants is one, we all know that that's where the water and the nutrients come from, is from the soil through the roots. But it also provides physical support, and some soils support plants better that way. It's also a place where gas exchanges. Roots need oxygen. They are burning carbohydrates to make energy, the same way that we burn calories, and burning requires mixing with oxygen. So how much air there is in the soil makes a difference to supporting plant life. Your good soils, your best soils, are about 50% mineral and 50% pore space.
Water and air.
That should be full of water and air. And then humus is an extra.
And when you compact it, you lose those pores.
You lose the pore space. And so if you look at this slice of soil, can you see all the little holes in it? Bigger holes, little holes. Those are made by roots and things that live in the soil, as well as the roots. Roots grow, and as they grow, they push and shoulder their way through the soil. They're pushing soil particles around and gluing them together with the excrement of things that live in the soil, and with the lubricants that the roots themselves make to push through the soil. It's amazing what's going on in that soil, because the plants are living in it. They're exuding all kinds of chemicals. And that's how they add organic matter. The root grows, and if it's not a woody root, it dies and adds organic matter to the soil. So the carbon that it took out of the air ends up in the soil. The plants provide an environment for microbes to live in. As soon as you get a root in the soil, you start getting the root cap oils and carbohydrates and starches that break off the slimy end of the root that helps it push through the soil. Yeah, and things come and live on that. It can alter the soil chemistry. Most of us know about walnuts creating chemicals that cause other plants to not grow so well. All roots are giving off chemicals all the time, chemicals that attract microbes, chemicals that encourage attachment to other roots. I mean, just all kinds of things end up out there, and they're pushing soil crumbs around. So when you look and you see the roots of this poor oak that was growing on a beach, on a dune, on the ocean, and is still growing on the dune on the ocean, you can see that there's a difference in the color of the soil and the crumbliness of the soil at the top as it goes to the bottom, and that's because the tree is there. All of those roots that we're taking out when we dig outside, they're taking out an entire layer of life, of nematodes and bacteria and fungus. And in a teaspoon of soil, you could have a billion, that's with a B, a billion different, microbes of thousands, tens of thousands of different species in a teaspoon of soil.
Teaspoon, yeah. Not a tablespoon.
Yeah, so the plants are important. And when you think about how many roots grow in, this is the real map of the tomato's roots, July 11th. So it's a full-grown tomato plant. And that's, those markings on the side are feet, 3 and 4 feet down. Well, this is in Nebraska, so it's a deeper soil than we might have here. But all of those roots, every one of them is pushing through the soil and encouraging soil life. Look at a pepper after 6 weeks. And again, that's feet, that's going down 3 and 4 feet. And deep roots, like dandelions, they're pulling nutrients from deep in the soil and bringing them back up to the surface where the leaves die and contribute the nutrients to the surface. And they're not the only deep-rooted plants, tap-rooted plants. Look at spinach. Look at beets. They're doing things for the soil. So we don't really want to get rid of everything in the soil if we can when we're improving the soil. And perennial plants do even more, because many of them continue to grow roots for years before that root gets replaced.
I would like to dig up one of those asparagus from the asparagus farm. We drive by and see how do something like that.
They did these root maps by trenching next to the plant and then mapping the roots that they found in the cross section. So they dug a 9-foot deep trench to follow the roots of this asparagus. And if you want to see things like this, you would go to the University of Nebraska's University of Nebraska Lincoln website and look for John Weaver's work, J.E. Weaver.
Yep.
And it's another rabbit hole to fall down. He did 35 years of this digging out there of root systems.
He and a bunch of graduate students.
Yeah.
But
So
he did get in and dig himself.
Yes, we've seen pictures of him in those trenches himself. Soil does degrade. It degrades naturally, but it also degrades a lot more by agriculture, industry, commerce. And what happens when soil degrades is that the physical properties change. It gets compacted, like Steve said, you press it down. It gets sealed, where it might not be compacted in a thick layer, but there's a cap on it so that the air doesn't move into it, water doesn't move into it. And that's a reduced infiltration rate. So look at the difference between an onion. So there's what an onion could be at the end of the year on the left. And here's what an onion set looks like after a few weeks in normal soil, in good soil on the left, and in compacted soil on the right. And you can get compaction at the surface where people cut across the corner, and so nothing grows.
Or pile snow.
Right, or pile snow.
If you're doing a snow pile, the snow pile may push into there, which
I lean forward when I can move it.
I don't know.
Okay. You can get compaction at the depth that the plow presses or the tiller repeatedly presses.
When it's spinning at that, you can only get down so far with those.
Yeah.
And when they spin it, if there's any clay in there, it will glaze that layer.
It'll glaze that layer. And we're using this tiller here in order to mix in compost. So we're doing it just 1 year, but you do that year after year, same depth, and you get a what's called a hard pan at the plow depth.
Yep.
If you run in a farm, every 3 or 4 years, you run a knife through the soil. You knife the soil deeper. And what happens when you get a compacted layer is that you get this kind of, this is a good soil. Let me back up here. This is a good soil. This was a cornfield.
Yeah.
And it was a good soil until, while it was wet, bulldozers ran over it repeatedly in order to get it all flattened out and leveled out to become a subdivision. And it squished that soil while it was wet, and it like a sponge,
really squished it.
like a sponge that you press down. If you don't let up on the pressure, the sponge never fluffs back up again. And this stuff was pressed down deep and never fluffed back up again. And you get, even sandy soil can get pressed down. This is a compacted layer of sand.
And it will just be just like clay, won't let it penetrate.
Yeah, it won't let water and air penetrate, or not as well.
Not as well, yes.
Okay, you can also degrade soil by changing the biological properties, the microbes that live in it. As in the case with that garage wall, where they were repeatedly using a home defense chemical, spraying it on that area over and over again, change the biome in that soil. And there can also be chemical changes where your fertility goes down or it becomes imbalanced, or you can change the acidity, or you can pour stuff in there that doesn't belong.
Ooh.
So our soil test, which we'll come back to a couple of times today to show you soil test results, our soil test shows that our phosphorus is above optimum, high phosphorus, which is not, it's not necessarily good to have above optimum. Might be great in school to say you're advanced, but when you have too much of one nutrient, one chemical in a soil, it can change the chemical reactions in the others, and it does indeed happen with phosphorus. But our potassium is way low, and that's fairly common in Michigan to have low potassium. How does that happen? It happens because people use too much high phosphorus fertilizers. Happens because the parent rock doesn't have enough potassium. Happens because you overcrop, because it gets eroded, because you put a lot of water in and flood things out and leach things out, or you overgraze or farm unsustainably.
Yeah.
I would call it flooding. Excuse me. Still breaking up the cold. I would call it flooding when you press the soil down so much that, show Joanne's soil in the back. just point it out so people can see those blue gray.
That's not good soil.
That's what I dug out of the bottom of that drainage hole test hole. Blue gray clay that was crushed down hard,
real hard.
And then all you got to do is add regular Michigan rain to it, and you flood that soil and change what's going on there.
It was amazing.